Welcome back to Physics with Miyoshi, and today we're going to talk about another problem with about Newton's second law. Again, remembering that the acceleration is the sum of our forces divided by our mass, and those would be vector quantities. Mass again is a scalar, or the sum of all our forces is our mass times our acceleration. Today, or this time, we're going to look at an application where we have a gun or some kind of thing that shoots a projectile, and it's going to shoot a projectile in such a way that we have a 4.9 times 10 to the 5th Newton force on it on a 5 kilogram projectile. That projectile gets acted on for a certain amount of time. We're going to find that time, knowing that the final velocity was 4 times 10 to the 3rd meter per second, and the initial velocity was 0 meters per second. There's a very high rate of speed, and we're going to find out that it's a really quick amount of time, or a very short amount of time. So, how do we do that? Well, first thing we got to do is we're going to recognize again that our Newton's second law formula here, acceleration is our sum of all our forces divided by our mass, and since we know that they're going in the same direction, we can ignore the fact that it's a vector. Just remember that they are vectors, and they are going in the same direction. So, we take our 4.9 times 10 to the 5th newtons, our force, divide that by our 5 kilogram mass, and we get 9.8 times 10 to the 4th meter per second squared, remembering that a newton is a kilogram meter per second squared, so our kilograms would divide out there and we'd be left with meter per second squared. Then we got to go back and we got to remember those kinematic equations. Yes, you're going to remember those for a long time because we're going to use them over and over again. So here we go. We know that our acceleration is one of our basic formulas. Acceleration is our change in velocity divided by our change in time. Again, remembering that our acceleration and velocity are vectors. We can ignore that a little bit because we know that they're going in the same direction. But we're gonna, and we can change our delta V to VF minus VI, or if you like, that could be changed to a VO if you'd like. And then we're gonna rearrange this equation here to be our time is VF minus VI divided by our acceleration. Okay, when we do that, we plug in our numbers here that we got. We got our 4.0 times 10 to the 3rd meter per second, and we have an initial velocity of 0, and then we're going to divide that by our 9.8 times 10 to the 4th meter per second squared, and when we do those calculations, we get 0.041 seconds. And that's smoking. It gets up to that speed in a very, very short amount of time. That's pretty quick. And again, we'll find out later that that's a lot of energy in this 5 kilogram object. But right now, we just find out that this is a very quick amount of time, very short amount of time to get that projectile going at that rate of speed. So, little application of Newton's second law, and coming back to our kinematic equations in one dimension, and that's how we figure out our time just by using those things that we know. So again, application of Newton's second law, and just remember, draw your free body diagram and label everything you need to know, and then figure out what equations you need. Again, this is simple equations we're going to use, and then we go back to our kinematic equations and go from there. So, thanks for tuning in. Hope to see you back again for more Physics with Miyoshi.